So next is fluid. So what are the average daily fluid and electrolyte requirements? So daily fluid requirement is 40 ml per kg per day of the fluid. Sodium is 1 to 2 millimole per kg per day. Potassium is 0.5 to 1 millimole per kg per day. What are the volumes and electrolyte concentration fluid excreted at different levels of GI tract? So saliva 1.5 liter, gastric secretion 2.5 liter, bile 1 liter, pancreatic 1 liter, small intestine 3 liter. So if we talk about saliva and gastric, it makes 4 liter, bile, pancreas 2 liter, spleen, small intestine 3 liter. So 2, 3 and 4. So what are the concentration of electrolytes in the gastrointestinal secretions? So they have compared the plasma with saliva, gastric, pancreas, bile and small intestine. So if we talk about plasma and small intestine, it's almost equal. Sodium 140, potassium 5, chloride 100, above 100, bicarbonate to 30. If we compare the pancreas with the plasma, so pancreas has more bicarbonate 115. Talk about gastric with the plasma, so it has sodium 60, potassium 10, chloride 130 and bicarbonate 0. And saliva 10 sodium, 26 potassium, chloride 10 and bicarbonate 30. So compare the electrolytes are contained in 1 liter of 0.9% saline, Hartmann solution and plasma light. So saline is 0.9%, it is 154 sodium, 154 chloride, osmolarity is 308 and osmolarity 287, and it is its pH is acidotic. And Hartmann and plasma light. So Hartmann has 131 sodium, potassium 5, chloride 111 and calcium 2 and lactate 29, osmolarity 278. In plasma light, it has more sodium than the Hartmann 140. Potassium is equal. Sodium was 140, sodium is 131 in Hartmann's, potassium is 55 in plasma light and Hartmann's, chloride little bit less in plasma light, calcium absent in plasma light, and magnesium 1.5 in plasma light. And plasma light has acetate 27, gluconate 23, 294. What are the volumes of fluid compartments of the body? So 40%, 28 liter is intracellular, 14 liter is extracellular, and out of 14 liter, 3.5 liter is plasma, 10 liter is interstitium, 1 liter is transcellular. A patient has a high duodenal fistula following failed repair of a perforated duodenal ulcer. What are the daily fluid and electrolyte losses? Why do they occur? So patient can lose up to 4 liter per day, including like saliva and gastric, and high concentration of excreted hydrogen, chloride ions. Hypochloremia leads to metabolic alkalosis. So patient will develop hypokalemia, hypochloremia, metabolic alkalosis, just like gastric outlet obstruction. What is your approach to fluid management for this patient? So ensure adequate hydration to maintain the organ perfusion. Patient will need 6 to 8 liter per day to replace fistula losses and cover the maintenance fluid requirements. Measure the electrolyte composition, the output of the fistulas to guide replacement, and strict daily input and output charting is essential. Replace the electrolytes, mainly potassium and chloride, ideally via the enteral route as World Health Organization solution or diaurolite. And consider a proton pump inhibitor H2 receptor blocker to reduce the secretion. Octreotide therapy may be used to reduce the fistula. Consider loperamide to slow GIT transit and delay gastric emptying. And concentration of electrolytes in the oral rehydration solution, it's WHO solution or diaurolite single strength. It has sodium 60, potassium 20, chloride 60 and glucose 90 and citrate 10. Thank you.